In 1944, the German strategy for defeating the Allied invasion of Europe was built on a single, logical assumption. An army needs a port. Field Marshal Gerd von Rundstedt, the Commander-in-Chief West, was an old-school strategist. He knew the logistics of war. He knew that landing men on a beach was easy. Keeping them there was hard. A modern army consumes thousands of tons of supplies every day. Tanks need fuel. Artillery needs shells. Men need food. You cannot supply an army of millions over a sandy beach. You need cranes. You need deep water docks. You need rail heads. You need a harbor. Therefore, the German defensive plan was simple: turn every major port along the French coast into a fortress. Cherbourg, Le Havre, Brest, Saint-Nazaire, Calais. The Germans fortified these cities with massive concrete bunkers, heavy coastal artillery, and thousands of troops. Hitler declared them Festungen, fortresses. Their orders were to hold out to the last man. And if they were about to be captured, the German engineers were ordered to destroy them completely. They rigged the cranes with explosives. They scuttled ships in the channels. They mined the quays. The German logic was brutal. Let the Allies land on the beaches, von Rundstedt argued. They will have a few days of supplies. But without a port, they cannot unload their heavy tanks or their fuel. They will wither on the vine. And then, we will push them back into the sea. German intelligence looked at the Normandy coastline. It was famous for having no natural harbors. It was just miles of open sand and cliffs. It was unprotected from the violent storms of the English Channel. To the German naval experts, landing at Normandy was logistical suicide. They laughed at the idea of sustaining an invasion there. They will be unloading crates by hand in the surf, the German officers joked. They will starve before they reach Paris. This confidence allowed the Germans to concentrate their best troops around the ports, leaving the beaches relatively lightly defended compared to the ports. They were preparing for a siege of the cities. They didn't realize that the Allies had analyzed the same problem. The Allies knew they couldn't capture a port intact. They knew the Germans would blow them up. So, they decided to do something that had never been done in the history of warfare. They decided to bring their own port with them. The solution to the port trap began in the most unlikely of places, Winston Churchill's imagination. Years before D-Day, as early as World War I, Churchill had toyed with the idea of artificial harbors. He was frustrated by the dependence on captured geography. In 1942, after the disastrous Deep Raid proved that capturing a fortified German port was a bloody impossibility, Churchill realized that a new approach was needed. He wrote a famous memo to Lord Mountbatten, the Chief of Combined Operations. It was short, demanding, and visionary. Piers for use on beaches, he wrote. They must float up and down with the tide. The anchor problem must be mastered. Let me have the best solution worked out. Don't argue the matter. The difficulties will argue for themselves. This memo set in motion one of the most secret and massive engineering projects of the war. Code name, Mulberry. The engineering challenges were immense. The English Channel has massive tides, a rise and fall of over 20 feet. A fixed pier would be underwater at high tide and high and dry at low tide. The pier had to float. But a floating pier needs to be anchored. And it needs to carry the weight of a 40-ton Sherman tank. And crucially, a harbor needs calm water. You cannot unload ships in rough waves. The ships will smash against the piers. Since Normandy had no natural breakwaters, the Allies would have to build artificial ones. They would have to calm the ocean itself. This meant building massive walls of concrete and steel in England, towing them across 100 miles of open ocean, and sinking them in exact positions off the French coast. It was a project the size of building the pyramids, but it had to be done in secret, and it had to be movable. The British engineers, civil engineers who usually built bridges and dams, were drafted into the war effort. They worked in secret locations. They built models in water tanks. They tested the strength of waves. They tested the buoyancy of concrete. The Germans, who prided themselves on their engineering, had no idea this was happening. They couldn't conceive of such a project. It seemed like a waste of resources. Why build a fake harbor when you can just capture a real one? They were trapped by conventional thinking. Churchill was not. He was willing to try the impossible because the alternative, failure on the beaches, was unacceptable. To create calm water, you need mass. You need something big enough to stop a wave that has traveled 3,000 miles across the Atlantic. The Allied engineers designed the Phoenix caissons. These were essentially hollow concrete skyscrapers. They were massive rectangular blocks, some as big as a 5-story building, 200 feet long, 60 feet high, and weighing 6,000 tons. They were built with internal chambers. They would be towed across the channel floating, filled with air. Once in position, valves would be opened. They would flood with water and sink to the seabed. If they needed to be moved, the water could be pumped out, and they would float again. Building these monsters required a construction effort that rivaled the Manhattan Project. Thousands of workers were hired. Dry docks all over Britain were commandeered. When the dry docks ran out, they dug massive holes in the mud of the Thames estuary, built the caissons, and then breached the river banks to float them out. Because the project was top secret, the workers didn't know what they were building. They were told they were building boom defenses or anti-submarine walls. The Germans saw them. Luftwaffe reconnaissance planes flying high over England photographed these strange concrete shapes floating in the rivers. German intelligence analysts were baffled. Are they apartment blocks? Are they fuel tanks? Are they silos? They couldn't figure it out. The shapes didn't make sense. Some German analysts guessed they might be parts of a jetty, but the sheer number of them, over 200 were built, seemed excessive for a jetty. They dismissed them as defensive structures. They didn't realize they were looking at the walls of a fortress that would be deployed on their own coastline. The concrete mountains sat in the estuaries of England, waiting for the signal. They were ugly. They were grey. But they were the shield that would protect the invasion from the fury of the sea. The Mulberry Harbors would take weeks to fully assemble. But the invasion fleet needed protection immediately. On day one. So, the planners came up with a stopgap solution. Code name, Gooseberry. The idea was brutal. Take old ships, ships that were too old to fight, too slow to run, or too damaged to repair. Sail them to Normandy. Line them up boat astern about a mile offshore. And sink them. These ships were codenamed corncobs. They included old battleships like the French corvette and the British Centurion, along with dozens of liberty ships and merchantmen. The crews of these ships volunteered for the mission. On D-Day and the days following, this ghost fleet sailed across the Channel. It was a one-way trip. Under heavy German artillery fire from the coast, the corncob ships maneuvered into position. The captains gave the order to blow the charges. Explosions ripped out the bottoms of the ships. They settled into the shallow water, their superstructures staying above the waves. It was a sacrifice of steel. Nearly 60 ships were scuttled to create 5 separate Gooseberry breakwaters, one for each invasion beach: Utah, Omaha, Gold, Juneau, Sword. The effect was immediate. Behind the line of sunken ships, the water calmed. The chaotic chop of the channel was broken by the steel hulls. Small landing craft, which would have been swamped by the waves, could now shuttle back and forth in relative safety. Amphibious trucks, DUKWs, could unload cargo. The Germans watched from the cliffs. They saw the Allies sinking their own ships. At first, they were confused. Why are they destroying their own fleet? Then, they realized the water behind the wrecks was smooth. They realized the Allies were building a wall of dead ships. It was a crude solution, but it bought the engineers time. Time to tow the massive Phoenix caissoons across the sea. Time to assemble the floating roadways. Time to build the real miracle, Port Winston. The corncobs were the foundation. They were the martyrs of the logistical war, dying so that the supply line could live. D-Day, June 6, 1944. The beaches were secured. Now, the construction began. On the other side of the English Channel, a fleet of tugboats revved their engines. Their job was to tow the Phoenixes, the 6,000-ton concrete caissoons, across 100 miles of open ocean to France. It was an agonizingly slow procession. A Phoenix caissoon is about as aerodynamic as a brick. It has no bow, no stern, and no rudder. The top speed of the tow was 4 knots, about 4.5 miles per hour. That is walking pace. It took over 24 hours to cross the channel. The tugboat crews were exposed. They were sitting ducks for German E-boats, fast torpedo boats, or Luftwaffe bombers. They were towing the most valuable secrets of the war, and they couldn't maneuver to dodge an attack. But the Allied naval supremacy held. The destroyers and the RAF kept the Germans away. The real enemy was the sea itself. Even in relatively calm weather, the caissoons were unwieldy. The tow cables would snap under the strain. The caissoons would yaw and drift. Some of them broke loose and sank in the middle of the channel. But the convoy kept moving. It was a conveyor belt of concrete. When they arrived off the coast of Arromanches, British sector, and St. Laurent, American sector, the precision work began. The caissoons had to be sunk in exact positions to form a continuous semicircular wall. It was like parking a skyscraper. Tugs nudged them into place. Engineers opened the seacocks, valves. Water rushed into the hollow chambers. Slowly, majestically, the concrete mountain would settle. Gurgle, splash. It hit the seabed. The top 30 feet remained above water, creating a solid breakwater. Then the next one was brought in. And the next. Day and night, the wall grew. It stretched for miles. Inside the wall, the choppy waves of the channel hit the concrete and stopped. The water on the beach side became as calm as a millpond. The tugboat captains, exhausted, turned around and went back to England to get another brick. They were building a monument to logistics, one toe at a time. Calm water is useless if you can't get the cargo from the ship to the shore. You can't just dock a ship against a concrete caisson, the tide would leave it stranded. You needed a pier. A pier that could move. This was the genius of the whale roadway system. The whale consisted of miles of steel bridges. These bridges were supported not by pilings driven into the sand, but by floating pontoons called beetles. The beetles were made of steel or concrete. They floated on the surface. As the tide rose, 20 feet up, the beetles rose with it. The roadway stayed horizontal. As the tide fell, the beetles settled onto the sand, or lowered, and the roadway went down. The bridges were flexible. They were connected by special articulated joints that allowed them to twist and turn with the movement of the sea without breaking. It was a floating highway. Building it was a nightmare. The sections were towed across the channel in 400-foot lengths. Under fire from German artillery, which was still active on the flanks, the Royal Engineers had to connect these wobbly, moving sections together. They had to anchor the beetles so the currents wouldn't sweep the bridge away. But when it was finished, it was a marvel. It stretched nearly a mile out to sea. At the seaward end, there was a massive spud pierhead. This was a floating platform with legs, spuds, that could be lowered to the seabed to anchor it. Ships could dock at the pierhead at any time of day or night, regardless of the tide. They would unload their trucks and tanks directly onto the platform. Then, the vehicles would drive down the whale roadway, floating over the waves, and drive straight onto the beach. No wading through surf. No waterproofing needed. A truck could drive from a Liberty ship to the front line without its tires ever touching salt water. The German engineers had said it was impossible to build a flexible bridge that could handle 40-ton tanks in the ocean. The British engineers built miles of them. By D-Day +10, June 16, a miracle had appeared off the coast of Arromanches. It was called Port Winston, Mulberry Bee. To the soldiers on the beach, it looked like a city had risen from the sea. There were breakwaters stretching for miles. There were piers. There were cranes. There were anti-aircraft guns mounted on the caissoons. There were barrage balloons floating overhead. At night, the harbor was lit up like a Christmas tree to allow for 24-hour unloading. The volume of traffic was staggering. Thousands of tons of supplies were pouring ashore every day. Tanks, artillery, ammunition, fuel, food, medical supplies. The harbor had a capacity greater than the port of Dover. It was handling more tonnage than many established French ports. And it had been built in a week. The logistical bottleneck that the Germans had counted on, the starvation of the Allied army, never happened. Instead of withering on the vine, the Allied army was growing fat. They had so much ammo they could afford to waste it. They had so much fuel they could run their engines all night. Port Winston was the heart that pumped blood into the invasion. It was a triumph of prefabrication. Every piece had been built in England months before, organized, labeled, and towed over. It was like assembling the world's biggest IKEA set under artillery fire. The speed of the assembly was a strategic weapon. The Germans were moving reinforcements to Normandy at the speed of trains and horses, which were being bombed. The Allies were moving supplies at the speed of industrial assembly. By the time the German panzer divisions arrived to counterattack, they faced an army that was fully equipped, dug in, and supported by a floating city that wasn't on any map. For the first week of the invasion, the Luftwaffe was almost non-existent over the beaches. But occasionally, a high-speed reconnaissance jet, an Arado R-234, would streak over the coast at 30,000 feet, taking photos. When these photos were developed and shown to the German High Command in Berlin, the reaction was disbelief. Field Marshal Rommel looked at the grainy images. He saw the lines of concrete caissons. He saw the floating roadways. He saw ships unloading where no ships should be able to unload. He realized, with a sinking feeling, that his entire defensive strategy was obsolete. He had fortified Cherbourg. He had fortified Le Havre. He had assumed the Allies would break their teeth on those fortresses trying to capture a port. Instead, the Allies had ignored the fortresses. They had bypassed the port trap. The photos showed a busy, functioning industrial harbor on a stretch of beach that the German maps labeled as unsuitable for heavy landing. It was a technological shock. The Germans realized that they were fighting an enemy who didn't play by the rules of geography. If the Allies didn't like the map, they changed the map. This realization caused panic in the German staff. They knew that if they couldn't stop the flow of supplies, they couldn't stop the invasion. They ordered attacks on the Mulberries. They used Aniga human torpedoes. They used magnetic mines. They used oyster mines. But the defenses were too strong. The concrete walls protected the inner harbor. The Mulberries had changed the equation of the war. The Germans were waiting for the Allies to run out of steam. The reconnaissance photos proved that the steam was just getting started. Rommel famously said, "The enemy supply is his greatest strength." Looking at the photos of Port Winston, he saw the physical proof of that strength. And he knew that the Atlantic Wall had been breached not just by soldiers, but by engineers. Just as the harbors became fully operational, nature struck a blow that the Germans could not. On June 19, 1944, D-Day +13, the sky turned black. The wind began to howl. A northeasterly gale, the worst storm to hit the English Channel in 40 years, slammed into the Normandy coast. It lasted for 3 days. That Mulberry Harbor at Omaha Beach, the American sector, took the brunt of the violence. The floating whale roadways twisted and buckled like snakes in the heaving swell. The mooring cables snapped. The concrete Phoenix caissons, which were designed to withstand waves, began to shift. The sand beneath them scoured away, causing them to crack and crumble. But the worst damage came from the landing craft. Hundreds of small boats, torn from their moorings, were hurled against the floating bridges like battering rams. Steel smashed into steel. The roadways disintegrated. By June 22, when the storm finally broke, Mulberry was a wreck. It was a twisted pile of scrap metal and broken concrete. The German High Command was jubilant. They believed that General Winter or General Storm had saved them again. They thought the invasion supply line was severed. They calculated that the Allies would now starve for ammunition. Field Marshal Rommel prepared a counterstroke, believing the Americans were cut off from the sea. It looked like the port-trap strategy might work after all. Nature had done what the Atlantic wall could not. But the Germans underestimated two things: the resilience of the British harbor down the coast, and the ingenuity of the American sailors who had lost theirs. A few miles to the east, at Arromanches, Mulberry B, Port Winston, was battered, but it was still standing. The British engineers had been luckier with the seabed, and perhaps more cautious with their anchoring. During the height of the storm, they had taken desperate measures to save the harbor. They sank extra blockships to reinforce the breakwater. They used tugs to push against the swaying bridges to dampen the movement. When the storm cleared, Port Winston was damaged, but functional. The Allies made a quick, ruthless decision. They abandoned the American harbor at Omaha. They cannibalized it. They took the surviving caissoons and roadways from the wrecked American port and towed them to Arromanches to reinforce the British port. Port Winston became a super harbor. Meanwhile, the Americans proved that they didn't need a fancy port to move cargo. They adopted a brute force method called drying out. They drove their massive LSDs, landing ship, tank, onto the beach at high tide. When the tide went out, the ship sat high and dry on the sand. They opened the bow doors, drove the tanks and trucks directly onto the beach, and waited for the next tide to float the ship off. It was risky. It strained the ship's hulls. But it worked. The Germans watched in horror. They had expected the destruction of the Mulberry to stop the flow of supplies. Instead, the flow increased. The surviving Mulberry B at Arromanches handled the heavy tonnage and the deep draft ships. The American beaches handled the volume. The storm had slowed the Allies down, but it hadn't stopped them. The German hope for a logistical collapse evaporated. The supply line was not a single thread that could be cut, it was a web that healed itself. By late July 1944, the statistics of the Normandy supply effort were mind-bending. Through Port Winston and over the beaches, the Allies had landed 2.5 million men, 500,000 vehicles, 4,000,000 tons of supplies. To put that in perspective, 500,000 vehicles is more than the entire inventory of the German army on the Western Front. The roads of Normandy were choked with Allied trucks. The Red Ball Express began its run, moving fuel to Patton's racing tanks. The German logistics, by contrast, were a nightmare. Their rail lines were bombed. Their horses were dead. Their fuel was gone. A German panzer division might wait 3 days for a fuel truck that never arrived. An American armored division could pull into a field depot and fill up 200 tanks in an afternoon. The Mulberry Harbor was the gateway for this abundance. It allowed the Allies to bring in the heavy equipment, the bulldozers, the cranes, the bridge-laying tanks, that gave them the engineering edge. It allowed them to evacuate thousands of wounded men, saving lives and boosting morale. German prisoners of war, marching past the stockpiles on the beach, were often stunned into silence. They saw mountains of crates. They saw fields of jeeps. They saw this material Schlacht, the battle of materials, and they knew they had lost. One German officer famously remarked to his captors, "I knew we had lost the war when I saw that you had special ships just to bring fresh socks." The Mulberry Harbor was the physical manifestation of the industrial might that crushed the Third Reich. It proved that the Allies could project their economy anywhere in the world, regardless of the terrain or the lack of facilities. When the war ended, the Mulberry Harbors were no longer needed. Captured ports like Antwerp and Cherbourg eventually came online, after months of repair. But Port Winston had served its purpose. It had bridged the gap. Today, if you visit our manches in Normandy, you can still see them. The massive concrete phoenix caissons sit in the ocean, battered by 80 years of tides, but still solid. They look like ancient ruins, the Stonehenge of World War II. They are a monument to one of the greatest engineering feats in history. They represent a victory of imagination. The Germans lost because they fought a conventional war. They relied on capturing geography. The Allies won because they fought an engineering war. They created geography. They looked at a map that said no harbor, and they drew one in. The German generals who mocked the amateur Americans and that exhausted British learned a hard lesson. They learned that you cannot defeat an enemy who can walk on water, drive on the ocean, and bring a port with them. The Atlantic Wall was broken not just by the bravery of the infantry, but by the concrete blocks that floated across the sea. Logistics is the quiet killer of armies. And at Normandy, the Mulberry was the weapon that delivered the fatal blow.